Hi students, I am Dr.K Varada Rajkumar, Associate Professor, Department of CSC, AIML, MLR Institute of Technology. In our previous classes, we discussed about many sorting algorithms like bubble sort, selection sort, insertion sort, quick sort, mid sort and heap sort. In this session, we are going to compare all these sorting algorithms in terms of time complexity. So, what we have the presentation? In this presentation, we are going to compare time complexities of different sorting algorithms. Outcome of this lecture, at the end of this lecture, you all are understand the time complexities of different sorting algorithms. Here, we are trying to compare these sorting algorithms: bubble sort, insertion sort, selection sort, quick sort, mid sort and heap sort. Here I am mentioning the time complexities in worst case, average case and best case for all these algorithms. So, coming to bubble sort, for bubble sort the worst case time complexity is big O of n square, for average case it is big O of n square, for best case it is big O of n. In bubble sort, if you give the input already in sorted order, then there is no need to swapping. So, in this case that we consider as a best case, the time complexity is big O of n. Coming to insertion sort is also same as bubble sort. The worst case time complexity is big O of n square, average case is big O of n square and best case is big O of n. So, why? If the already numbers are in sorted order, then it takes only big O of n, there is no need to swap. So, the time complexity in best case for insertion sort is big O of n. So, coming to selection sort, for selection sort all worst case, average case and best case are big O of n square. And coming to quick sort, the worst case time complexity is big O of n square and the remaining average case and best case are big O of n log n. For quick sort, why it is big O of n square means, if the elements are in sorted order, then when we try to partitioning the array, maybe there is no left or right side. So, for quick sort, the worst case time complexity is big O of n square. So, coming to mid sort, for all the cases it is big O of n log n. For heap sort also, for all the cases the time complexity is big O of n log n. I hope you all are understand the time complexities of different sorting algorithms what we learned in our previous classes. Coming to summary of the lecture, we discussed comparison of different sorting algorithms. So, bubble sort has poor performance and is generally not used for large data sets. Why? The time complexity is big O of n square. So, similar to bubble sort, selection sort is not efficient for large data sets. Why? The worst case time complexity is big O of n square. Insertion sort performs reasonably well for small data sets but becomes inefficient for larger ones. Why? It is also worst case big O of n square. So, mid sort is a comparison based sorting algorithm with consistent performance especially for large data sets, but it needs extra space to store elements. Okay. So, when comparing to previous sorting algorithms, mid sort performs well, but here the disadvantage is here it takes extra space to store elements. The space complexity for mid sort is big O of n. Okay. For all these bubble sorts, insertion sort, selection sort, space complexity is big O of 1. Why? We do not need any extra space. So, quick sort is an efficient algorithm. The worst case occurs when the pivot is always the smallest or largest element. Okay. If it is the smallest, then there is no left side. If it is the largest, then there is no right side. Okay. So, heap sort has consistent performance and is in place but has a larger constant factor compared to quick sort. Okay. So, this is the end of sorting techniques. From last few classes, we discussed about different sorting algorithms. Okay. In next class, we are going to discuss tree data structure. If you have any doubts, so place your doubts in the comment section. I will answer all your doubts. Thank you.